Today I'll be covering Ohm's law and Kirchhoff's rules. Ohm's law, or V equals IR, relates to three main electrical quantities: voltage, current, and resistance. Kirchhoff's current law states that at any junction, the current going in equals the current going out. So given this circuit, we have the current I1 from the battery, and it must split into I2 and I3 at the junction. Mathematically, I1 is equal to I2 plus I3. Kirchhoff's voltage law states that the sum of all voltage changes in any closed loop is zero. So given this simple circuit with two resistors, we have a voltage drop across the first resistor and one across the second resistor. And mathematically, V minus V1 minus V2 is equal to zero. Let's do a simple example problem to practice using Ohm's law. Given this circuit, find the current going into the first resistor. Well, the first thing we want to do is get the equivalent resistance, because we know that since the first resistor is in series with the battery, it must take all the current from the battery. So, using our resistance laws, we can find out the equivalent resistance for the circuit is 6 ohms. And rearranging Ohm's law to solve for current, we can get 2 amps as the current going into the first resistor. Let's solve a more complicated circuit using Kirchhoff's rules. Let's find all the currents flowing through this circuit. Well, we have the current coming from the battery, and since there's a junction, it must split into I2 and I3, which you can draw going towards or away from the battery. Now, the next thing we need to do after we have one equation is find two more, as we have three variables. And we can do that by picking a closed loop and then applying Kirchhoff's voltage law and Ohm's law to it. Well, let's start with the left loop. We know that the voltage from the battery minus the voltage drop across resistor 1 and resistor 3 has to equal 0, which I, by the way, have labeled in the bottom left corner. Now, we can use Ohm's law to substitute for voltage, and we get this expression. And since we know the resistance of each resistor in that expression, we can get this final expression as our second equation. Applying that same logic to the second loop, or the one on the right, we can get this expression. And now we have three equations and three variables, which means we can just use a calculator to solve. And these are our three values for current. A negative current just means you picked the wrong direction for current 3, and that's okay. Thank you guys for watching.